Hello everyone. I welcome you all for online video tutorial by Department of Civil Engineering, Sai Vidya Institute of Technology. Myself, Professor Gautam, working as Assistant Professor in the Department of Civil Engineering. So today I am going to explain about design of overlay. So as I already explained in the previous class, what is the definition of overlay and at what circumstances we are going to lay overlay on the flexible payment. So in today's class, so we will see certain problems which will related to design of overlay. So now we are going to solve the problem by using the data of Benkelman beam deflection studies, and also here we are using the formulas which is related to IRC 37 2001. Okay, so based on this we are going to design our overlay. So now let us see the first problem. So here the Benkelman beam deflection data were analyzed and the modified characteristic deflection value after applying the corrections for pavement temperature and subgrade moisture was found to be 2.2 mm. The design traffic in terms of CSA is found to be 20.1 MSA. Using the overlay design chart, determine the design thickness of overlay if DBM binder course and BC surface course are to be adopted. Now let us see the solution part. So design value of cumulative standard axle here saying in the problem as how much? It is equal to 20.1 MSA. I just noted that. Corrected characteristics deflection. Guys, remember, see in this problem straight away he said that he had given deflection value considering correction for pavement temperature and subgrade moisture is equal to 2.2 mm. Okay. By chance, if he straight away given if it is a mean deflection value, you have to apply for the correction for temperature and subgrade moisture. That deflection value you need to consider for the calculation. But anyhow, in the problem straight away he has given that after applying the corrections for both temperature and the moisture, deflection value is 2.2 mm. Therefore, you can consider this value straight away. Now, we have to use the chart in order to fix the thickness of overlay. How to use the chart? Here, this x-axis represents characteristic deflection value, and this side y-axis represents the thickness values, and this side right side it represents the, that means this curve, whatever curve present here, which will represents the design traffic in CSA. Okay, sorry, not CSA, in MSA. MSA stands for million standard axle. Okay, now in our problem he is saying that the traffic is 20.1 MSA and deflection value is 2.2 mm. Then let us try to mark this point on this graph in order to get the thickness. Mark 2.2 in the x-axis first, deflection. So 2.2 means it will come at this point, right? Then our curve is what? So, okay, 20.1 MSA. Here you can see the 20 curve, the curve which represents the 20 MSA traffic, this curve. So from this point, you just eject a straight line to the curve 20 MSA. Again, from this point, you eject back to the y-axis in order to know the thickness. Okay. So somewhere it will intersect here. So that value I considered it as 195 mm. Okay. Now the thickness of dense bituminous overlay required with equivalency factor of 0.7. Therefore, equivalent factor of 0.7. Therefore, total thickness is 195. Therefore, 195 multiplied by 0.7, that is equal to 136.5 mm. You can approximate it to 140 mm. Out of 140 mm, you can consider 100 mm thick for DBM layer and 40 mm thick for bituminous concrete surface. Okay, guys, this is how you need to solve the problem. Again, one more problem I am going to take. In that problem, this value they didn't given straight away. The traffic traveling on that road, that is traffic in MSA and deflection value, they didn't given straight. You need to calculate that values by using IRC 37 formula, and you should apply correction for temperature and moisture. Let us see that problem. So this is the problem. Traffic studies conducted on a stretch of 6-lane divided highway with flexible pavement indicated that there are 3,600 commercial vehicles per day in one direction. The average growth rate of commercial vehicle is found to be 5.5% per year, and mean vehicle damage factor value is 6.8. The estimated period of completing overlay construction is 2 years after the traffic studies. Okay. Benkelman beam studies were conducted on the stretch of highway and the results obtained are given below. Mean deflection value is equal to 1.28 mm. Remember guys, here mean deflection value he had given. He didn't given the deflection considering temperature and moisture. Therefore, here in this problem, you need to apply correction for temperature and moisture. That value you have to consider for the calculation of deflection or calculation of thickness of overlay. Okay. So standard deviation of deflection value is 0.26 mm. Temperature of bituminous pavement during the study is 45 degrees centigrade. Clayey soil with plasticity index 12 in the subgrade. Then moisture content of the subgrade during the deflection is 10%. Then annual rainfall is 1550 mm. Finally is asking design overlay thickness using DBM binder course and BC surface course for a design life of 10 years. So, okay, anyhow, charts they will give charts for moisture correction factor and overlay thickness may be used as 10.13b and 10.14. Okay, now let us see how to solve the problem. See in the problem, MSA, that is traffic, he has right away given it as 20.1 MSA, correct? No, but in this problem, you need to calculate initially the traffic. Okay, how to calculate that? Okay, before that, just write out the data, whatever data I has given. Present traffic is equal to 3,600 commercial vehicles per day. You can designate it as P. Growth rate, that means annual growth rate of the traffic is 5.5% per year. Then construction period of the overlay is said that it requires 2 years, designate it as X. Then vehicle damage factor of the commercial vehicle, you can designate it as F, that is equal to 6.8. And design life of the overlay is 10 years. So all data is given. Then details of the existing payment as per Benkelman beam studies. Mean value of the deflection is equal to 1.28 mm. Standard deviation is 0.26 centimeter. Pavement temperature during the deflection study is 45 degrees centigrade. Then subgrade soil clay, that is plasticity index 12, which is less than 15. You need this data in order to refer the graph. Moisture content during the deflection study is 10% and annual rainfall is 1550 mm, which is more than 1300 mm. I will tell you why this data is required: plasticity index and annual rainfall. Okay. Now, first we will calculate million standard. That means first we will calculate the traffic. Okay. How you need to calculate the traffic? First, calculate initial traffic for the design by using the formula capital N is equal to 1 plus R to the power of X into P, where X is the construction period, that is 2 years. R value is growth rate 0.055 and P is the initial traffic, it is 3,600. Therefore, it comes that total 4,007 commercial vehicles per day. Now, we are having the formula from IRC 37/2001 to calculate the traffic. So that is given by 365 into NFD into 1 plus R to the power of N minus 1 divided by R. You know what is the value of N? N is 4,007. F value he has given in the problem as 6.8 and D value is 0.6. You can consider 1 plus R is growth rate and again N is design life, that is 10 years. So all the values are available. You just calculate what is the cumulative traffic. So that is 76.8 MSA, 76.8 million standard axle it will come. You can consider it as 77 million standard axle. Now, in order to refer overlay thickness graph, this data is available, this curve data, because we need two data, correct? No, deflection data and curve data. Curve data is now available. Okay, design traffic cumulative standard axle, that is available. How much? 77. But x-axis we need to calculate deflection by applying the corrections. So how to apply the corrections? This is the procedure. So since it is a divided highway, characteristic deflection is given by mean deflection plus 2 into standard deviation. Mean deflection in the problem he has given it as 1.28, right? You can observe mean deflection value is 1.28 he has given in the problem. So standard deviation is 0.26. So I use that 0.2 into 0.26, that is equal to 1.8 mm. Next, correction for pavement temperature with respect to 35 degrees centigrade, that is given by 45. It is a given temperature in the problem. Therefore, 45 minus 35 into 0.01. So 0.1 mm. This much you have to deduct from this characteristic deflection. So that characteristic deflection corrected for pavement temperature is equal to 1.8 minus 0.1, that will be equal to 1.7. Now, seasonal correction factor for clay is subgrade for plasticity index less than 15 and rainfall is more than 1300 mm, and for moisture content 10%, you need to take it from the graph. Let us see the graph. See, this graph is for sandy gravity soil for low rainfall area where annual rainfall is less than 1300 mm, and second graph is for clayey soil having plasticity index less than 15 and rainfall is greater than 1300 mm, and here plasticity index is greater than 15 and rainfall is also greater than 1300. Okay, but here our problem plasticity index is 12, right? Therefore it belongs to, and also rainfall is greater than 1300. Our rainfall is how much? 1550. So therefore, which is greater than 1300, we can use this graph. Okay, for this condition, we can use this graph. So moisture content is 10%. From the 10%, you just eject a line like this and eject back to here. So this value you have to consider it as correction factor, that is equal to how much? So so here you can see 1.2 and here it is 1.4. You can absorb this value as 1.3. So I write it as 1.3. Now corrected characteristic deflection for both temperature and subgrade moisture is equal to how much? 1.7. This value 1.7 multiplied by correction factor is 1.2. Now we come to know that deflection value is how much? 2.21 mm. Now for the deflection 2.21 mm and for the traffic 77 MSA, you have to see the chart to find out the thickness of the overlay. Okay, now let us erase the previous one. So traffic is okay. Here the x-axis value is how much? 2.21, right? So this is 2.21 means somewhere it will intersect here only. Okay, traffic is 77 MSA. So here it is 20 and here it is 100. In between here it is 50, correct? No, in between if you consider it is 50, 60, 70, 70 means a curve will come somewhere like this. Sorry. Okay, curve will come somewhere like this. Okay, so here it is 2.21 deflection. Just to project a line to the curve what we had drawn. So it will intersect somewhere at this point, correct? No. So project back to y-axis and check out the value. Okay, project back to y-axis properly and check out this value. Okay, so this is I approximated as it is more than 200 only, right? So I approximated as how much? 230 mm. Again, out of 230, you need to consider total thickness of DBM plus BC overlay. You have to consider an equivalency factor of 0.7. Therefore, 230 into 0.7, it will be equal to 161 mm. You can round it up to 160 mm. Therefore, out of 160 mm, you can consider it for 1 ton thickness for DBM layer and another 50 mm thickness for the BC layer. And this is how you need to do design of overlay thickness by using Benkelman beam studies values. Okay, thank you guys. I hope all of you understood today's class. We'll meet in the next class with another topic.